Okay, sit down. Okay, we have started this topic last time, which is about traffic flow and traffic flow characteristics. We discussed what we mean by traffic or what outcome we are going to cover, what we mean by traffic stream, what are the major reasons of variation in traffic flow, the types of highways according to traffic flow, and the types of parameters. Okay, so we have macroscopic, which is the big one, and the microscopic, which is the small one. And in each one of them, we have three parameters, and we started with the macroscopic parameter. Okay, we started with the first macroscopic parameter, which is volume. Okay, and there are two more things which are related to volume, which is flow and flow rate. Okay, all of them have the units of vehicles per unit time. Okay, all of them have the units of vehicles per unit time. Okay, which one of them can be per hour? Volume. Okay, which one of them can be per day? Which one of them can be per day? All of them can be per day.
Per unit time.
Why did you say volume for 1 hour? Yes, which one of them can be per day?
Volume for day, flow for less than 1 hour.
Yes.
Flow rate when we convert from
Very good.
to volume.
Very good. Okay. Yes. Okay. Agreed? Okay. So volume is can be per day or per hour. Flow is less than 1 hour, and flow rate is per hour but converted.
Can we convert?
Yeah. Not can be. It is converted. Without conversion, it remains flow. Okay. Flow rate has to be converted. Okay. And we discuss where do we use them, and we discuss the case of flow and the peak hour factor as well. Today we'll move on to the next macroscopic parameter, which is speed and travel time. Throughout this course, you will see we are discussing speed and travel time together. Okay, throughout this course, you will see the speed and travel time are discussed together. Okay, why? Because they are linked with each other. Okay, what is the link between them? What is the relationship between them?
Distance.
Yeah,
Oh, you mean
per unit time, both of them. Distance per unit.
when speed increase, the time decrease.
Yeah, so what do we call this?
I call it
Yeah. If one thing increases, the other one decreases, what do we call this relationship?
opposite the
Inversely proportional. Okay, inversely proportional. They are inversely proportional. Okay, and you can calculate one from the other, right? If I give you travel time, you can calculate speed. If I give you speed, you can calculate travel time. Okay. Now we are discussing speed as, when we say travel time, it cannot be for a short distance. You can call it time, yes. Travel time is between place A to place B. Okay, so travel time is between two different locations. Okay, you cannot say, okay, my travel time, I will take travel time for 10 meters. It will not be even 1 second for a car. Okay, so travel time is taken for locations which are far from each other. Got it? Clear? Okay. Now we are saying we are using speed as macroscopic. Okay, macroscopic. So, what was the difference between macro and micro?
Macro larger.
Okay, and micro is what?
Smaller.
What do you mean by smaller in terms of traffic?
One car or few of both.
Yes, micro is for 1 or 2 cars. But when we say speed as macros, it cannot be for 1 car. It has to be for a group of cars. Okay, so then we have to take the mean. Got it? Okay, without the mean, it will not become macro. It will remain for 1 car. Got it? Okay, so we have to take the mean. Now, in the last lecture, I told you, there are different methods to take average of volume. There were 4 different methods. Similarly, there are 2 different methods to take mean of speed. We are discussing speed as macro, so it has to be for a group of cars, and then we have to take the mean for that group. But that mean can be taken in 2 ways. One is called time mean speed, the other one is called space mean speed. Okay? Both of them are speeds mean. Okay? Both of them are mean speeds, both of them. Okay? You take a group of cars and you take the mean of their speeds. So if you read here, mean of speeds, mean of speeds. For a specific time, for a specific time. For a lane on a highway, for a lane on a highway. Okay? The only difference is these 4 words. Okay? What is it saying? Speed when what? Over a point. And what is it saying? Speed over a section. Clear? This is the only difference between them. Okay? The first one is very easy. Okay? I have a car, it passed in front of me, I had a device, it captured the speed, and this device kept on capturing the speed of 100 cars. I have 100 values, I take their mean. Which mean is that? The first one. Time mean speed. Okay? Clear? Time mean speed is clear? Huh? The one which we know. Huh? You take speed, lots of speeds, take the mean, and this is it. Clear? Okay. The second one is for a section. Now, would you agree that the speed of the car does not remain same on all points of the section, right? It keeps on going up and down. Okay. So, in the second case, before I do the mean of different vehicles, I should do the mean of all speed of the same vehicle. Because at every point, its speed can be different. I want the whole section, right? I want the whole section. So maybe at the start point of the section, the speed was 20. Next point, it is 21. Next point is 30. Next point is 18. It can happen, right? So one vehicle may have different speeds in one section, right? So for the second case, space mean speed, I need the average speed of one vehicle for the entire section. And I have to do it for multiple vehicles and then take the mean. Alright?
So we take the mean of their speeds.
We take the mean for one vehicle and then take the mean for multiple vehicles to get space mean speed. Alright? This is the theory behind it. We don't do it like this. Okay? But the theory is space mean speed means that I take the overall speed of the vehicle from start to end for every vehicle, do it for many vehicles and then take the mean, and then that mean is called as space mean speed. So time mean speed is easier, get the speed over a point, do the mean, done. Space mean speed has one extra step. First take the speed of the same vehicle at all the points, then do its mean. Then do it for the other vehicle and then take the mean. Correct? Okay? Clear? Sure. What's your name?
Ali.
Ali. You were with me, right? Last course? Or before that?
Yes, 1904.
Okay. So, got it? So, for time mean speed is very easy. Okay? You know, you have a device, you take the speed. Okay? Space mean speed. The problem is, I have to take the speed at all the points, right? How many points in a section?
Many points.
Yes.
Many points.
Many points. Point is what? A dot, right? I can have a new dot after every millimeter, right?
Yes.
Even for one section which is very short, you can have millions of points. Clear? Okay? So many points. To get the speed at all the points, even for one vehicle, very difficult, right? Almost impossible. Okay? So now, what do? We use these equations to calculate time mean speed. The equation is very simple. D upon T is the speed of one vehicle. Summation of all the speeds divided by number of vehicles, time mean speed, TMS. Okay? Clear? Huh? If you have the radar or the device which gives you the speed, then I will not do d upon t. I just put the value of the speed, okay? D upon t represents what? Speed. D upon t is what? Speed. Okay. In the second case, I wanted the speed of the entire section, right? I cannot have the speed of the entire section because I cannot measure it. So what do? I can measure the travel time of the entire section. I cannot measure the speed, but I can measure its travel time. When did you start? When did you finish? Okay. Now, that travel time has all the speeds, right? We said what? The speed goes higher, travel time goes lower, right? So maybe in the first 10 meters, the speed was high, travel time is lower. Then the vehicle slowed down, travel time became higher. Then slowed down further, travel time became higher. Then it accelerated, travel time becomes lower. So the final travel time has all the speeds. Okay, whether it was going up or down, the final travel time has everything now. Okay, so now I don't have to worry about the speed. Okay, because I know the total time now. Okay, so I know the distance and I know the total time. Okay, so now I can calculate the speed using this method. So we are doing distance upon, what is this term in the bracket? T means travel time. So it becomes what now? The bracket becomes what? This one. What can I call it?
TMC.
Mean travel time. Okay? I was trying to get the space mean speed, remember? SMS, which I cannot get directly because I need the speed of all the points. So what do? I do distance upon mean of travel time. Clear? Okay? Okay. We have the data for 6 vehicles. For every vehicle, the distance is given, the travel time is given. Okay? We are required to calculate the time mean speed and the space mean speed. Okay? For time mean speed, we have this equation. The first one. So for every vehicle, I have to do d upon t, right? For every vehicle, I have to do d upon t. Okay. Tell me. First vehicle, how much?